Well, it's time to learn, and today we're going to present 12 design patterns that are really essential for beginners so that they can get started successfully in Satisfactory. And remember, today's video is sponsored by Ping Players, but more on them later. Load balancing is already difficult enough when you have to split a single conveyor into 12 or more lines, but how do you split it evenly when you have to split it into the oddest of numbers, a prime number? If you need to feed 5, 7, 11, 13, or maybe higher, how do you handle breaking it down evenly? The answer is by using a prime splitter array. The concept is simple. Build a splitter using prime factors of your target number plus 1. In this example, we need to split our conveyor into 5 machines. So we build an array that splits our input into 6 lines, then take the extra output line and feed it back into the starting conveyor. This distributes the extra items back to the original 5 outputs. I love a good load balancer. It precisely divides the right number of items to the right machine just in time. It helps take any number of inputs into the right number of outputs. But it does have drawbacks. It can be bulky, they have to be completely rebuilt if you need to add or subtract a single machine. So what other options are there? Manifolds are the opposite of the load balancer. They use a single conveyor to merge all the items together and send them to each machine in order. The downside? A factory with a lot of manifolds can take a long time to spin up, as each machine in order has to overload before sending the excess items downstream. The upside? A compact distribution system that looks great. Have you ever needed to balance the number of items on multiple conveyors? Conveyor balancers might be an excellent solution for you. Let's demonstrate with a 2x3 balancer, which takes 2 inputs, A and B, into 3 outputs, 1, 2, and 3. The simple solution would be to merge the 2 inputs and then split it into 3 equal outputs. But if the combination overloads the merged belt, you need this second solution. Let's reverse the mergers and splitters. Split each input conveyor into belts equal to the number of outputs. This ensures that no belt is overloaded. In our case, we split each input into 3 outputs. Then we merge 1 belt from each input belt, so we merge A1 with B1. That becomes one of the outputs. Do that for each of the outputs, and you have a perfectly balanced conveyor. How do you go from building small-scale rat-tail factories to building mega factories without getting tied up in spaghetti? The basic building block of the mega factory is the manifold lane, which helps you to scale up while minimizing the extensive conveyors that eventually get you all tangled up. Manifold lanes are simple. It involves 2 rows of constructors or other production buildings, and 3 manifolds that feed them. First, build the 2 rows of constructors with about a single tile between them. Then build a manifold by creating a row of mergers and send their output back to where the raw materials enter. Last, build the 2 manifolds along the outside to feed the raw materials into the constructors. To make things quicker, build this inside the blueprint designer for fast deployment. Each of these lanes is only limited by the capacity of your conveyors. Manifolds are one of the best ways to build large-scale factories in Satisfactory. But how do you build a compact manifold for assemblers or manufacturers? For assemblers, use a double manifold layout that's 5 foundations wide. Place the assemblers at the edge of the boundary and align a splitter with the first input port. Stack 2 splitters in line with the second port, then disassemble the lower one. Connect your conveyors to complete the setup. For manufacturers, start with a base of 6 foundations wide. Build 4 stackable conveyor poles at each end and connect them with conveyor belts. Place splitters on each belt, aligning them with each of the manufacturer's ports. Use lifts to connect each port to its corresponding splitter. For full blueprints, join my Discord. I love using manifolds in Satisfactory. They're efficient and compact. But at higher tiers, the long startup times become a problem. For example, a manifold that makes iron rods with Mark IV conveyors will fill 32 constructors. It takes over a half an hour to get it full. With Mark V or VI belts, it could take hours to reach full production. So what's the solution? Use a hybrid manifold. Hybrid manifolds use lower tier conveyors to fill machines in parallel instead of in sequence. To build one, create a branch off your main line using a conveyor that's a tier lower than your max speed. Complete the branch like a normal manifold, then keep branching until you have the needed machine count. With a hybrid manifold, your production lines ramp up much faster, letting you hit full capacity in record time. I've been using manifolds in my factories since shortly after I started playing Satisfactory. Now, almost everything I build incorporates a manifold because they're easy to expand and maintain. So let's break down how to plan and build the perfect manifold. We'll use a manufacturer making supercomputers as an example. A manifold size is limited by the speed of the conveyor belts bringing items in or taking them out. For supercomputers, the required ingredients are computers, AI limiters, high-speed connectors, and plastic. Among these, plastic is the highest demand at 52.5 units per minute. The design of your manifold depends on the input to output ratio. When fewer items are produced than consumed, like in this case, place inputs on the outside and the outputs going down the center. For recipes like wire, where more items are produced than consumed, reverse the design and put the outputs on the outside and the inputs down the center. For balanced ratios such as alclad aluminum sheets, a single-sided manifold might work the best. Using a Mark V conveyor, we can divide 780 items per minute by the 52.5 plastic per minute needed, giving us 14.8 machines. For a two-sided manifold, we can overclock a few machines to bring the number of machines down to 14, with 7 on each side. Finally, decide where the outputs go. In my mega factory, I route finished goods to the opposite side of the inputs, forming a loop that feeds my mall below. But you can also route them back to the same side for simpler setups. To build the manifold, place 7 manufacturers per side with the inputs facing outward. Use stacked conveyors with lifts to keep everything neat. Most of my builds are done manually, but I've created blueprints for each machine, which you can download on my Discord. Playing Satisfactory with friends shouldn't mean dealing with lag, crashes, or confusing server setup, and ping players make sure you don't. Ping players' high-performance servers keep everything running smoothly with low latency and reliable uptime. And you don't have to mess with port forwarding or custom configs. Servers launch in minutes with easy control panels and automatic backups built in. So you can focus on building, exploring, and expanding together without worrying about whether the connection will hold or the world will load. Right now, you can get 35% off any Satisfactory server with the code DOC35 at checkout. Ping players, multiplayer without the mess. If you're building a mega factory and have multiple sources of the same item, you might have a bunch of conveyors that aren't entirely full, which leads to wasted space and inefficient design. How do you fix that? Conveyor compressors help by merging all items into one conveyor line until it is full, and then sending the remainder into another. The basic layout is very simple. Take your first 2 inputs and attach a smart splitter to them. Set one output to any, another output to overflow. Now merge the 2 any outputs. This line will always be full. Then merge the 2 overflow lines. This will be your remainder. If you have another line to be compressed, repeat the design using the previous overflow remainder as an input. Now your factory can hum along at maximum capacity. Over a year ago, I shared how to make a conveyor compressor, a setup of splitters and mergers that took multiple partial belts and ensured at least one of them always stayed full. It was niche but incredibly useful. Unfortunately, the old version required clipping belts to fit everything on a stack.
I have record of those days. You used to ask me for help. You used to value me.
I'm sorry? Now, thanks to the priority merger, you can do the same thing with half the sorters and no clipping. Here's how. First, place a priority merger on the belt that you want to fill. Set its input line to high priority. Next, place a smart splitter on your overflow belt. Set its main output to overflow and the side output to any. Finally, connect the smart splitter's side output to one of the side inputs of the priority merger. That's it. a clean, efficient conveyor compressor with no clipping. And if you need to combine even more lines, just repeat this setup.
Stay efficient, pioneer. You don't want to make a mistake now that you're alone.
By the time I got to mid-game in Satisfactory, I had completely given up on load balancing. Manifolds were easier to build, and skipping the exact math was liberating. So when I unlocked aluminum in Tier 7, it threw me for a loop because aluminum has a circular dependency that demands the same careful balancing I'd sworn off. It starts with bauxite and water in a refinery producing alumina solution. That alumina solution then combines with coal in another refinery, making aluminum scrap, and a byproduct of water. If you don't use that water, it backs up your scrap production, which means that aluminum production in almost every case requires you to master that circular dependency. Here's a couple tips that'll make sure it works out. First, instead of good enough napkin math planning, fully balance your factory before you build. Targeting a multiple of 480 aluminum ingots means you don't have to fine-tune water extractors, and most of your machines will be working 100% of the time. Second, put an open valve right after the return water manifold from your scrap refineries. That will minimize sloshing that can sometimes cause your machines to pause for a cycle. Lost cycles can compound for catastrophic results. Finally, check your alternate recipes. Instant scrap skips the loop entirely but introduces sulfuric acid to the mix. The pure aluminum ingot removes the need for quartz, which simplifies the whole build. Aluminum becomes the backbone of many recipes, much like iron in the early game. When my sons and I built our first aluminum plant, we targeted 2,400 ingots per minute, which is 2 fully loaded Mark VI belts, and we haven't run out. After a few months of playing Satisfactory, I gave up on load balancers and went all in on manifolds. They just scale better later in the game. But there's something about load balancers that really scratches the itch. Sending the perfect amount of items to each machine with no backups and no delays waiting for that last machine to finally turn on, it begs the question, can you actually use load balancers in late game? Well, absolutely. Here's how to make them work. One trick is to use lower tier belts to throttle the output from a higher tier line. As long as the main belt holds at least twice the throughput, you can pull exact quantities. For example, a Mark II belt will always grab 120 items per minute, which splits cleanly into lots of useful numbers like 30, 40, or 60 per machine. If you're trying to divide into a prime number like 7, you can always use a loop back. Just split the line into 8, then loop one of those lines back and merge it with the original. That'll give you a nice even split across all 7 machines. And if your brain starts to melt while trying to map this out by hand, don't worry. Someone in our Discord dropped a link to a load balancer calculator on GitHub that handles even the most cursed setups. It's in the description, along with a link to our server if you want to join the chaos. Now that I'm building my Gigafactory, I've found that my previous manifolds and blueprints are just not cutting it. Trying to build an endgame item like a ballistic warp drive requires about 270 machines, and that would just take forever. So I've created what I call store blueprints. I got the idea from working at Boeing, where all over the factory floor were stores that provided component parts and mini assemblies that went toward building the final plane production. Each store building it as a manifold that is pre-programmed, overclocked, to produce a single item like stators, rotors, and motors. By creating a store for each of them, I no longer had to balance dozens of machines, but instead, just 3 stores. The goal with the stores is to make a factory that accepts only ingots to produce a final product, thus reducing the complexity to something much more manageable. Thanks for watching, and thanks to Ping Players for sponsoring this video, and we'll see you later. Bye.